is Catherine Gould, and today I am presenting my Lab 4. So, as an overview to this lab, we were basically analyzing the motion of an oscillating spring system, and the spring had a mass on the bottom, and we were analyzing its motion in the x and y directions. So the goals of this experiment were to compare the tracker observations to the computational model developed in GlowScript, and then plot the energy changes. And the key principles that we're using here are the energy principle, the momentum principle, and Hooke's law. So from the edX videos, we were given a few pieces of data to use. The first being the mass. The mass given was 0.402 kilograms. Next is the spring constant K, 6.83, and L sub O, which is 0.123 meters. Okay, so after that, I uploaded the video into Tracker and I tracked its motion. On the right side, you can see that it's moving in an oscillating pattern, and below that are all the values for it. So next I used what I found in Tracker and I put it into GlowScript to create a computational model. So we can see that I've inputted the given mass, which is 0.402 kilograms, and I've put in the position of the ball, which I got out of my Tracker values. Next, just putting in some of the other constants, gravity, spring constant, L sub O, and then defining L, L hat, and S. And then finally below that, we're applying the equations for kinetic energy, potential energy, and total energy. Next, I changed T to 9.4 because the amount of time that I was analyzing was roughly 9.3 something seconds, so I want to analyze the entire motion. Defined the initial energies, and then below that we are updating the forces, the position, the velocity, and this is all using Newton's second law, otherwise known as the momentum principle. Next, we're applying the energy principles, and this is going to calculate all the energy changes. And then down at the bottom, we have T equals T plus delta T, so that's just updating the time. And here are my results. Let me play this video. As you can see, that's exactly the way that the mass was moving in the Tracker video. And it's portraying this oscillating motion. That's about it. So here's the graphs that were given based off of the Tracker video and then uploading it into GlowScript. On the left, we have the change in energy versus time, and this is displaying all of the potential energies, kinetic energy, etc. And then on the right, we have the mass's position versus time. So what does it mean? This question is asking if the energy principle is satisfied, and the answer is yes. If you can look on this graph, you can see that one full oscillation starts at 0 energy and ends at 0 energy, so the energy is conserved. Next, if we look at the data I obtained in Tracker, make two estimates of the oscillation periods. So basically a period you can see in the bottom right is from like the peak to peak or from trough to trough. So I looked into the data table given in Tracker, and I found the highest number for X and found the next time it was highest again. If you look at these numbers, you realize that they're in an oscillating pattern. I did the same thing for Y, and I found that they have almost the exact same times. For the first time, both of them matched up to 0.76 seconds, and for the second time, they were only different by a few seconds. So that means that the periods for X and Y are only different by just a menial amount. So you can say that they're the same and the periods are the same. This concludes my presentation. Thank you for listening.